Let's find out what is a polynomial. Well, before that, let's do a quick recap of what is an algebraic expression. We have seen that whenever we have an expression that contains variable or variables, we call that an algebraic expression. So let's randomly write some examples of algebraic expressions. So 2x, let's say 6y squared minus 5y plus 10. Let's say r minus 6 by r. And let's write one more, square root t plus 6t cubed. So here we have written 4 algebraic expressions. In the first example, x is a variable. In the second example, our variable is y. In the third example, our variable is r. And in the final example, our variable is t. So each one of them is an example of an algebraic expression. Now then, what exactly is a polynomial? Here we are trying to find out what is a polynomial, right? A polynomial is a special type of algebraic expression when the variable or variables are raised to a whole number. Now what is a whole number? Let's quickly recall. Whole number is simply a collection of numbers that start from 0 and then they go like 0, 1, 2, 3, 4, 5, so on and so forth, all the way to plus infinity. So collection of these numbers, we call them whole number. So whenever we have an algebraic expression where all the terms that contain the variable and the variable is always raised to a whole number, then that particular algebraic expression, we call it a polynomial. Now that we understand what is a polynomial, let's find out some examples of polynomial and algebraic expressions that are not a polynomial. So 2x, is this a polynomial? Of course, I have written 2x in the column of polynomial, so we know it is a polynomial. But why is 2x a polynomial? Because we can write 2x as 2 times x, and we can write this as 2 times x to the power 1, right? X is simply the same as x to the power 1, and 1 is a whole number. So this is a polynomial. How about simply the number 5? Actually, the number 5 is called something called as a constant polynomial, and we're going to learn about this later. But for now, it is important to understand that we can write 5 as 5 times, of course, 1, and then we can write this as 5 times x to the power 0. Why is that? Because remember that any of the variables, when you raise them to the power 0, it is actually equal to 1. So x to the power 0 is 1, y to the power 0 is 1, r to the power 0 is 1. So whenever we have a variable raised to the power 0, it is 1. So instead of 1, we can write this as x to the power 0, and 0 is a whole number. So this is called as a constant polynomial, but for now, this is definitely a polynomial. Let's take a look at one more example. So 6y squared minus 5y plus 10. Is this a polynomial? This is a polynomial because here we have 3 terms. So in this case, we had 1 term, here we have 1 term, but here we have 3 terms. But for each of the term, the variable is raised to a whole number. So here the variable is raised to power 2, which is a whole number. Here the variable is raised to power 1, and here we can pretend that the variable is raised to power 0. So each of the variables, they are raised to a whole number. Hence, this is a polynomial. So these are all examples of polynomial. Now, what are not polynomials? How about we have 2 by x? This we can write it as 2 times 1 by x, or we can write this as 2 times x to the power minus 1. 1 by x is same as x to the power minus 1. Now, minus 1 is not a whole number, and hence this is not a polynomial, right? So let's take a look at one more example. So square root t plus 6t cubed, and let's say maybe minus 15, right? So is this a polynomial? So we can write this as t to the power 1 by 2 plus 6t cubed minus 15, and we can write this as t power 0. We can imagine this to be like that. Now for the first term, this is raised to the power 1 by 2, and 1 by 2 is not a polynomial. But the second term is fine because 3 is, sorry, I should say 1 by 2 is not a whole number. So here 3 is a whole number, 0 is a whole number. So these two terms are fine, but this one, this is not a whole number, and hence the entire thing is not a polynomial.